video focuses on the Signal Breakout Module and how it is used to extract data measured with one of SAII Instruments' monitoring and gating systems. We are using the Model 1030 monitoring and gating system for this demonstration. The ERT module, powered by a battery, would normally be connected to a rodent in the scanner, but in this case, it is connected to a simulator. The simulator is generating an ECG waveform with a respiration waveform superimposed. Our setup also includes an ERT control gating module, the Signal Breakout Module, and a PC running PCSAM software. We are using a second display, which is easier to see in the video. In a magnetic field, a waveform with both ECG and respiration information is obtained by allowing one of the ECG leads to move as the rodent breathes. PCSAM software detects the peak of the cardiac waveform and automatically removes the cardiac waveform, leaving the respiration waveform shown here. We call this waveform generated from the ECG lead, iris, as opposed to peres, where the respiration waveform is generated from a pneumatic pillow. Data coming from the simulator goes to the ERT module and then over a fiber optic cable to the control gating module. Normally, data from the control gating module would go directly to the PC, but in this case, we want to extract data using the Signal Breakout module, which is connected in the data path between the control gating module and the PC. The cable connections include a serial to USB cable between the Signal Breakout module and the PC, and a serial cable between the Signal Breakout module and the control gating module. The Signal Breakout module has 4 microprocessors. Each processor streams data out on 3 ports labeled bit, DAC, and serial. The bit port contains gate data. The DAC port contains analog voltage data. The serial port contains digital data. The DAC and serial ports can contain slow data like heart and respiration rate or waveform data. Data streaming out of the Signal Breakout ports is user-controlled, with PCSAM software using the Signal Breakout window. The window has settings for all 4 microprocessors, but we are only going to use channel 1 for this demonstration. Usually, the bit port would be set to aux-in, where the aux-in B and C on the control gating module would contain a gate signal from the scanner. This allows the captured physiological data to be synchronized with the image data retrospectively. But, in our case, we set the bit port to the ECG gate. The DAC and serial ports we assign to the iris waveform. Checking the box at the bottom of the window allows the settings to be sent to the Signal Breakout module. We want to capture the iris digital waveform data on the channel 1 serial port of the Signal Breakout module using WaveGrab software. This requires a serial to USB cable to be connected between the serial port and the PC. We also need to determine the communication port automatically assigned by Windows for that USB port. The way to determine the COM port assignment is to open Device Manager. We type Device Manager in the search box and then open the Device Manager. Opening COM and LPT, we see that 2 COM port assignments have been made. The COM3 assignment is for the USB port connecting PCSAM to the control gating module. The COM4 assignment must be for the Signal Breakout serial connection. When we unplug the USB cable from the PC, because Windows updates Device Manager in real time, we can see that only the COM3 assignment remains. Reconnecting the cable, we again see that COMs 3 and 4 are assigned. The first time WaveGrab is executed on a PC, a window opens with the PC's ID number and a box where an authorization number can be entered. The authorization number can be obtained by contacting SAII Instruments and giving them the PC ID number. Once the authorization number is entered, WaveGrab's main display opens. There are a few settings to be made before collecting data. First, we need to set the COM port assignment. We know the COM port is 4. Then we need to name a file where our data will be collected. We name the file test and put it on the desktop so it will be easy to find later. The WaveGrab window gives us a box at the top that allows inclusion of the bit data with the captured waveform data. As previously discussed, This bit data would normally be from the aux port, but in our case, it is the ECG gate. Now we are ready to collect data in the file previously assigned. There are two choices for data collection. One choice is to collect a user-defined number of samples. The other choice, which we will use, is to collect data continuously. The window provides an indication of the time interval for data collection. We only need a few seconds for this demonstration, so we hit the stop key. Opening the test file on the desktop, we see two columns of data. The first column is the ECG gate. The second column is the ERS waveform data. When the test file is opened in Excel, we make the delimited selection, press Next, make the tab selection, and press Finish. ERS data is output 225 samples per second, or one sample every 4.4 milliseconds. We have created a column in the spreadsheet for time using that information and then plotted time versus amplitude. You can see that we captured data for a little over 10 seconds. The ERS scale in PCSAM goes from -1/2 millivolt to +1/2 millivolt. The data is output with a value from 0 to 127 counts. In our plot, the amplitude goes from 0 to 127, where 0 is -1/2 millivolt and 127 is +1/2 millivolt.
Additional information is available in SAII Instruments operation manuals and on www.i4sa.com. Thanks for watching.